All right, this is just an introduction to graphs and global graphs and just a bit of important information. So, when we talk about graphs, we basically talk about something on a Cartesian plane, well, on a x and y axis, and some line or squiggly or graph or something that's happening. These are always read from left to right, so this way. So we read it going that way. The first type of graph or definition which you know is a linear graph, and this is when there's a straight line. The straight line occurs because there's a constant rate of change. So here's our x and y axis, and there's a straight line here and there's a straight line there. Now we're saying there's a constant rate of change, which means that as the x value changes, the y value changes in a direct proportion to it. So if the x increases by 2 each time, maybe the y increases by 3 each time, but every time it's 2 here, 3 there, 2 there, 3 there, and then you get that straight line plotted. So that's the constant rate of change. It's changing at the same rate. A non-linear graph is when it's curved or changes direction. Basically, it's not straight anymore. So there's a curve or some squiggly or whatever the case is, that's not a straight line. For this happens because the rate of change is not constant. For this, think of your age. Every year, your age increases by 1. So every 1 year, your age increases by 1. So in year 10, your age is 10. In year 15, your age is 15. So that's happening over here. Or think about the time left until your death, which is a bit deep, but let's focus on the graph. So let's say you have 10 years left to live. After 1 year, you have 9 years left to live. After 2 years, you have 8 years left to live. Until eventually you reach 10 years later and you have 0 years left to live. But the rate of change is constant because every time the year is changing, the number of years of age or death until your death is changing at the same rate. Now with non-linear graph, think of something like this here, like temperature. The temperature from the morning could have went up a little bit, maybe from 10 degrees to 12, 13, 14, then it stayed at 14, and then went 15, 16, and it shot up a little bit. But basically, every hour doesn't guarantee a 1 degree change. It changes uh, based on weather patterns, based on the sun, based on different factors. But the change is not constant. It could go this way, then it could come down and then go up again, or whatever the case is, but it's not a constant change. Think of this as the height of a ball. Suppose you are standing and you throw a ball. Imagine this is the curve that ball makes. This is the height above the ground. Initially, it's 10 meters. Then you threw it, it went to 15, 20, 23 meters, and then it went and landed on the ground. But it's not changing the height by the set number every second. It's not always going up or always going down. It's changing. It's got a curve. The next type of graph we got is a constant graph. A constant graph just basically means the y value does not change. So, for example, uh, what example could I give you? Let's think about this. Let's say I gave you 10 Rand today, and you spend the next 3 years without changing the amount of money you have. So, if I ask you after 2 years, okay, if I ask you after a month, I know I still got 10 Rand. If I ask you about after 2 years or 1 year, no, I still got 10 Rand. It's all right. After 2.5 years, okay, no, I still got 10 Rand. So basically, that amount is not changing, which results in a horizontal line. This is a constant graph. It's called a constant graph because in algebraic expressions, if you have 2x plus 4, for example, this constant value, if you just eliminated this and this is all your expression was and you plotted it on a Cartesian plane, this is what it would look like. The next graph is an increasing graph. It goes up as you read from left to right. So starting from the left, as I go, I'm realizing now the graph is getting higher above me. So this is an increasing graph. This is also an increasing graph, but it's not a linear increasing graph. So as I'm going this way, it's increasing, but not linearly. Then you get a decreasing graph, which as you read to the right, it's going down. So this way is going down, or it's going down. This could be maybe this could maybe be the price of a barrel of oil as it's increasing and then it's shooting up, and then this could be the market value of a company as the years are changing, and then all of a sudden this company is tanking and it's gonna fail, so something like that. We then have things called the maximum and the minimum of a graph. Right, the maximum is the highest point of a graph. Now that only happens if the graph is not continuously increasing. So here, that ball you threw, it reaches a point and then it goes back down. So it reached a maximum height. That highest point is what we call a maximum. Suppose this reached a height of 23 meters, then the maximum value is that y coordinate of 23 meters. A minimum is the lowest point on a graph. Again, it's your y value. Suppose you went diving and then you dived 10 meters below the sea, and then you went 50 and then 70 and then 80, and then at 80, I don't even know if 80 is safe, but suppose you went 80 meters below the sea. Then this point, 80 meters below the sea, is the lowest point. Alright, so 80 meters below the sea is the lowest point on your graph. That's just an example. So whatever the lowest point is, that's gonna be your minimum. We then have something called discrete graphs and continuous graphs. Think of it as if you had an interview at school, or a quiz, or a tally that you asked a bunch of learners, like how many learners are there in specific classes. And let's say you asked the grade 4s, the 5s, the 6s, the 7s, 8s, 9s, 10s, whatever the case is. And let's say the first class had maybe 10 learners. The second class had 15. The next one had 14. That had maybe 22. Maybe 15 learners. And then these are just the number of learners plotted over here. Now, there's no connection between the number of learners. There's no way that this can tell you how many learners there are there. There's no relationship between these. These are unrelated. So discrete graphs are when values are separate or distinct. We plot them using individually plotted points, and there is no lines joining the points. So as you see, I didn't connect it like that. There's no line. Examples would be the number of learners or the number of goals a team scored. Think of it like this. If I connected a line, that means between grade 4 and grade 5, there's a number here, which might get cut in half, meaning that a grade between 4 and 5 would have 2.5 learners, or 11.5 learners, or 12 and 3/4 learners, which is not possible. Learners is a distinct number that can only be counted in whole numbers, like 1, 2, 3, 4, 5. You can't have a half learner or a quarter learner or 3/4 learner. So these are discrete values. The number of goals as well. It's either a goal or a no goal. You can't have a half goal or a quarter goal or a maybe goal. It's a yes or no. A continuous graph is now when you can have any value. So we join points by a line or curve. Ideas of these are time and temperature. The temperature can change. You might have 12 degrees, and then 12.1 degrees, and then 12.3 degrees. And then it can continuously change. There's a continuation between different values. Basically, if you had to think about it, in the morning the temperature is 10 degrees. By the afternoon it's 20 degrees. How did it get from 10 to 20? It gradually increased. The 10 never just turned into a 20. It went up by half a degree, or by a point degree. So 10, 10.1, 10.2, 3, 4, 5, 10.9, 11 degrees, 12 degrees, 13 degrees, until eventually it climbed up and reached 20 degrees. So a curve shows you that there was a bit of climbing happening there, and that would be continuous data.